Okay. Right, so mixed analysis of variance. So far we've talked about single, between, and within. Simple, between, and within designs. The simple between design, between subjects, is the one-way analysis of variance that we all know and love, our old friend. And then the within is, we talked about last time, repeated measures, which is a special case of a randomized block design. They're called simple because they have one variable. We've talked about factorial designs between subjects. The classic, 2 by 2, different group subjects in A1, B1, and A1, B2, and then ad nauseum, ad infinitum. And we've talked about factorial within designs. We talked about that at the very end of the last time. So that would just have the same subjects. Say you had a 2 by 2, you have the same subjects in each cell. Okay? We've talked about all those. What about combining them? What kind of crazy world do we live in? Let's do that! I'm way more excited about this than I should be. It's my own way of keeping myself interested. Well, you might actually say to yourself, well, why? Actually, why would you do that? There's cases we want one between variable, one within variable. Let's say different species and learning. So learning is a repeated measures thing, is a within subjects thing. And species, well, we can't really change species partly between. If it weren't for designs like this, I wouldn't have all those letters after my name, because I'm a comparative psychologist. That's kind of work that I'm trained to do. Sex differences, another thing that's pretty fascinating, right? Male-female differences in, say, spatial ability or verbal ability, whatever. We can't randomly assign subjects to different groups, but we can, just like the species, but we can say with men and women, and then we're going to test them on learning of different kinds of tasks. Sure. Okay, so these are two big kinds of questions that are asked a lot in psychology, and in fact, so they're using one between, one within, or mixed designs all the time. So it's not uncommon. And then, of course, the ever-present, etc. Etc. So you can think of other examples, I'm sure. All right. Here's an example. So we've got implicit and explicit memory. Implicit memory like for word family completion, things like that, or step completion. So anybody, a couple of you guys took memory with me? Yeah. So you remember that, right? Implicit and explicit memory. Okay. So you really have different subjects in different groups. So one group gets implicit tasks at 5 minute retention intervals of 5 minute, 1 hour, 24 hours. Another group gets explicit tasks 5 minute, 1 hour, 24 hours. There might be some concern, for example, about the explicit test sort of contaminating the implicit test. It's actually not that big a deal, but when people first started doing implicit versus explicit memory comparisons for retention interval, this kind of experiment, Talving Schachter at Stark 1982, when this experiment was done, they were concerned about that kind of thing. It turned out later not to be so worried about it, so people don't do it that way anymore. It's much more convenient to have the same subjects and test them all at once. Whatever. That was a concern, and a valid concern, it seems to me. So you want to have two different groups because they get two different test types, but then repeated measures on the decay for the decay function, retention interval. Okay? We still want the decay function though. And we're only going to get that if we test the same people over and over again. So you see the logic behind this? I hope. So what are the sources of variation? So we have implicit and explicit, and we got 5 minute, 1 hour, 24 hour retention interval. Group 1 is subjects 1 to 10, group 2 is subjects 11 to 20. I just arbitrarily figured we're going to have 10 subjects per group. Okay. Well, first is test type, implicit versus explicit. So memory test type is one source of variation, yes? Of course. Another one is retention interval, because that's another way independent variables we're looking at. Obviously, we have a subject, we're going to have an interaction of these two. But subjects themselves are a variable, right? Remember we figured that out last time, that we have to count subjects as an independent variable, which is the easy way to do, or the roundabout way to do, a repeated measures design in SPSS. You just use the GLM procedure, and you have each subjects 1 to whatever, that's another variable. That's a giant hint on how to do your assignment. So what have I got written there? Subjects, this is how you say this, subjects nested within test type. Or just you say subjects within test type, but it's called a nested variable. Subjects 1 to 10 are within implicit memory. Subjects 11 to 20 are within explicit memory. So they're within something. They're nested within. You can't talk about subjects without telling me what group they're in. Right? Do you see that? Make sense? Yes? So we have what's called a nested variable. Now in this case it's the subject variable. We have a nested variable. So what we have now is we can build a analysis variance summary table pretty easily. Remember last time I said talk about your subjects, then talk about your within subjects variables. Actually, we can add an extra layer to this thing. We do between subjects variables, then the subjects, then the within. Between subjects within. You're going to hear me say that so many times over the next 3 weeks. You're going to want to kill me. Which is weird, because it's just some words, and like it's a hate crime. But you'll learn to hate analysis of variance. No, you won't. You'll love it. Like it's your own child. That's a little strong. Probably not that strong. Probably somewhere between hate crime and loving it like a child. God, this has taken a very dark and odd turn, and I'm going to just reset. Look what I did here. It's pretty simple. Subject, between subjects variable, what is it? Test type. Different subjects with different levels of test type. So we're going to call it test. We're going to put that first. It has 1 degree of freedom. There are 2 levels of test type, implicit and explicit, and we lose a degree of freedom, so 2 minus 1 is 1. And then we talk about the subjects. Subjects are within test. Right? We have n minus 1 subjects, little n minus 1. It's 10, minus 1 is 9. And we have, that happens twice. 2 levels of test. So 9 times 2 is 18. Can you cross? Remember, you always go interact this with this. But you can't go test by subjects within test. That's weird. You can't have the same thing in there twice. So within, retention interval, there are 2 degrees of freedom for retention interval. And then we go, look, retention interval by test. Retention interval by subject within test. Oh, we're done. This thing called Yates order, this between subjects within. When you do it that way, you can figure out what the error terms are. You can also, if you want, derive the expected values of the mean squares. Let's do that. If you feel like it, go nuts. You're insane, because there's this algorithm works every single time. So we know if Yates order says use the first term below it that has it, the thing you're interested in, and subjects in the term. So you say, what are we going to test the test variable with? Oh, subjects within test. Retention interval, so mean squared test for mean squared for subjects within test. 1 by the other. Mean squared for retention interval by, oh, here's 1. Retention interval by subjects within test. Retention interval by test, retention interval by subjects within test. Yay! So that's how you can figure this out. This allows you to figure out what you test with how you do the F test. What mean square you divide by what other mean square. That's what it's doing. So the test you're doing is an analysis of variance, right? So you're dividing one mean square by the other mean square. That's what you're doing. Question so far? Okay. That's good. Either that's good or it's horrible and none of you understand it. I reject that hypothesis out of hand with no data whatsoever. I have complete faith in my awesome ability. Seriously, any questions so far? Good so far? Okay. So to review so far, we do between subjects within. Between subjects within. You say it to yourself over and over again. I'm going to say this a lot. Because until the last week of March, this is all we're doing. I'm going to show you all kinds of other designs. And then we're going to quit analysis of variance eventually, and we're going to talk about multiple regression. And you're going to think we're done with analysis of variance. And then I'm going to explain to you the way you analyze multiple regression is with analysis of variance. Just when you thought you were safe, pull it back in. So it's between subjects within, do the interactions, right? That's all we've done there. Test, subjects within test, retention by subjects. Oh, sorry, retention by test, retention by subjects within test. Done. This eventually becomes mechanical to do this. And the error terms are easy because we know we go, okay, test, we've got to find the thing that has subjects and test in it. It's just below it. Oh, there it is, subjects within test. By the way, this assumes everything else is a fixed factor and subjects are a random factor. And that's a fair assumption, okay? That's a fair assumption. Okay, questions so far? Here's another example. We're going to say n equals 5 in this example. Like the way that came in? Pretty impressive, right? Next to star web. Okay. Look at this one. We got 3 factors. Which of these is a between subjects factor? Or do we have any between subjects factors at all? So of A, B, and C, what is a between subjects factor? Yeah, Mitch.
1 and 2.
A is the factor. 1 and 2 are the levels. But yes, A is a between subjects factor. Why is that? That is because different subjects get different levels of A. It's a between subjects factor. If it's a between subjects factor, that means that subjects are nested within A, definitionally. So you could say subjects are within A. We know that. Now, within subjects, are there any other between subjects factors? Let's see. Looks like everybody gets C1, and everybody gets C2. Yeah. So it's a within. Everybody gets B1, everybody gets B2, and everybody gets B3. They are within subjects factors. Okay? They're repeated measures or within subjects factors. You okay, Glenn? Okay. You just look like you had a thing going on. Okay. So between subjects within. So the between is the A, the subjects are within A, the within are the B and C. There. Between subjects within, between A is a between factor, within are B and C. And there's the worst arrows ever drawn in a presentation. So instead of drawing arrows, I just say, oh, I don't feel like drawing. We'll do a minus and a greater than sign. So what we're going to do with this now is we're going to list the betweens, and that's just one, A. Then we're going to go subjects within A. And then we're going to go B and C. You could go C and B, but everybody always goes B and C because B is first in the alphabet. I mean, that's literally, you could go the other way, it wouldn't make a difference. But it's like, we've learned B comes before C. It's entirely arbitrary. Prove yourself that the order of the alphabet is arbitrary by quickly saying the alphabet backwards. It's hard. Counting backwards is easy because that's not arbitrary. Holy jumping, look at that source of variation degrees of freedom table. So, but this is exactly what we did before. It's just an extension. We added one extra within variable. That's all that's happened here. So I listed A first, then subjects within A. Let's not worry about degrees of freedom right now. We can calculate those in a second. Oh, look, I did list C first. Oh, I'm quite the rebel. I could have done B first because we can. C. And then, okay, now that I've listed these, C by A, C by S within A. Can I do C by C? Well, no, that would be ridiculous. What's the C by C interaction? So I'm done those. Now I go B. B by A, B by S within A, B by C by C by A, B by C by S within A. Whoa. Now, degrees of freedom. So first of all, before I get to degrees of freedom, does everybody see what the sort of mechanics of doing this are? Between, subjects, within, and you just do the interactions of everything above. Okay? It's mechanical. And the only way you get good at doing this is making up your own and practicing. And practicing. Practicing. And when you're finished practicing, you practice. When we get closer to the final exam, which is coming sooner rather than later, I will set up a Facebook a group for the class for studying and for asking each other questions, and I will be posting examples and giving you answers a couple days later. Also, I will expect you guys to be chiming in and doing those things too. But you see what it, see? Between, subjects, within. Do the interactions. The way you screw this up is you do within, subjects, between. Then it doesn't work at all. I mean, you could do it, but that mechanical thing I'm talking about, that algorithm stops working. So you have a between, subjects, within. So, how many levels does A have? Well, it has 2, so it has 1 degree of freedom. So that's a good start. N is 5, right, little n? Because there's 5 subjects per group. 4 times 2 is 8. Okay? C has 1. Then we have 1 again. C minus 1 times n minus 1 times A is 8. B has 2 degrees of freedom. B by A has 2 degrees of freedom. B by S within A, B minus 1, n minus 1, n, excuse me, 16 degrees of freedom. B minus 1 times C minus 1 is 2. B minus 1 times C minus 1 times A minus 1 2. B minus 1 times C minus 1 n minus 1, 16. Now add them up. 9, 10, 11, 19, 21, 23, 39, 40, 41, 42, 43, 59. The chances of you getting the degrees of freedom right and doing everything else wrong is pretty slim. It can happen, but that's just dumb luck. So if you add those degrees of freedom up, if it works, you probably did everything properly. It's a nice little check you can do on the work. Also, you'll see it gets this sort of Christmas tree pattern. Because the terms are bound to get bigger and then smaller as you add a new term. The interactions, then smaller, and then a little bit bigger. So it starts to have a look that you appreciate. You look at it and say, I see what's happening. Great.
Okay, so for S within A.
Yes.
So 5 minus 1, 4.
Yes.
And then what?
Times 2 levels of A.
2 levels of A.
Right, because subjects are within A. So there are 4 subjects here, or 5 subjects here, so that's 4 degrees of freedom. And 5 subjects here, that's different subjects, 4 more degrees of freedom. So now we have 8.
But there's 3 groups, right?
And those 2 groups, group 1 and group 2. Let's go back.
Oh, so I was thinking it was A, B, C.
Yeah. See, if it was B, if they were within B, there'd be 3 groups. But there's only 2 groups. Yes?
Okay. Could you just go through, so S within A.
Yes.
So N is 5.
Yes.
5 minus 1 is 4.
Yes.
And A is 2.
And there's 2 levels of A.
So A is, the levels of A?
Yeah, number of levels of A, that's all that is.
Okay.
Level.
Yeah.
C.
This is way easier than you probably figured.
So then C would be 2 because there's 2 levels of C.
Yes, C is 2 because it has 2 levels. B is 3 because it has 3 levels. A is 5 because it has 5 levels within each level of A. Except it's people.
Can we wait? Say that again.
And has 5 levels within each level of A. Right? There are 5 subjects, so 5 levels within each level of A.
And then where would you see what you just said in the table?
And minus 1 times 2.
Okay.
There are 5 levels. Nobody? Star Trek?
So basically, all you need to calculate is, well, not calculate, but look at is B, A, C, and N.
Yeah, that's all you're going to get degrees of freedom, right? And the thing is, if you take a look at that design, there are 10. Right. Yeah, there are. Sorry, not 10. There are 6 cells. Yes. Right. Yeah, and they each have 10. Sorry, there are. That's not right. There are 12 cells, and they each have 5 people, 5 observations in them. That means there are 60 observations. That means the design has 59 degrees of freedom. Right? It has 59 degrees of freedom because there are 60 observations. 60 minus 1 is 59. The total number of degrees of freedom must equal 59. Right? You see that? So it's a way you can look at it and go, this has to add up to 59 minus degrees of freedom. If it doesn't, I did it wrong. Oftentimes, by the way, when you get it wrong, it's because you don't do this in your head very well, so you have to go back and go, okay, I see.
Are there always going to be the same number of levels for each variable that you're looking at?
Oh, no. No. Sometimes there are. The world doesn't work that way.
For our purposes?
No. Why would I do that? Because that's not how the world works. What's going on here? Oh, it's dudes, so there's a lot of emails. Get on these email lists. All right. So questions, because it looks like you're all asking each other questions. Joey.
Where do you find the number of observations per set?
Oh, I told you that there were 5 subjects each group. Yeah, I would always tell you that. I would not tell you that. Just like, and in real life you would know because you collected the data. Yeah. Other questions? Because if you get how to do this now, the rest of this is going to be a breeze.
Dave?
Yes.
So right here, mine is showing that it's multiplied by n, but yours says a.
Oh, that's probably a typo in the old version, that's all. Yeah, this is correct, don't worry.
So that should be a.
Yeah,
Okay.
apparently, yeah. Obviously, there's obviously an old mistake.
Oh, my whole thing's wrong.
Yeah, there's obviously an old mistake on there.
This one's an a too.
Actually, I'll fix that.
Okay.
I'll upload it. Questions? Very straightforward, yes? It's mechanical. It's mechanical.
Yes.
Let's do another one. These are fun. Okay, what's the between subject variable here? There's one with no between the subjects to within. So what's a between subject variable here? Somebody other than Mitchell, because this is the last one. Keegan. B is definitely a between subject variable. Look, different subjects get different levels of B. G1 and G3, G1, G3, G4. Oh, 2, 4, 2. Correct. Are there any others? Are there any other between subject variables? Keegan. No, C. Look at C. C. Everybody gets every level of C. Oh, that's the sort. Yeah. A and B are both between subjects variables. They're both between subjects variables. What that means is then that subjects are going to be nested within A-B interactions. Subjects are within AB. So let's put that one over here. Both A and B are between and C's are within. Subjects are within AB. Because think about this. This is how you want to look at this. Can I talk about subjects without mentioning what level of A and B they're in? No, I cannot. So you're going to see subjects are within AB. All this is, frankly, is a regular 2 by 2, and then I put on a repeated measure of C. Between subjects within. Let's say there's 6 per group this time. So total degrees of freedom we should get, we've got what? 1, 2, 3, 4, 5, 6, that's 12 times 6, 72. We should have 71 degrees of freedom. What am I saying? 6 times 12. Oh, no, that's right. Is that right? No, it is. It is right. Yeah. Sure. That's fine. 12 times 6 is 7. Yeah. Why did I think it wasn't? What was going on with my times tables in my head? That's horrible. Anyway, 71 degrees of freedom. So we know when we get to the end, we should have 7. It should add up to 71. We do all the degrees of freedom. So this one's a little bit. Oh yeah, look, it is 71. I suddenly have this image of my grade 3 teacher saying, taking us 4 times tables, and I'm screwing up to 12 times. 12's hard for some reason. 11's easy, it's all double numbers. 10's easy, just 12's hard. And I'm imagining my grade 3 teacher, Mrs. Hopmackie, which is a great name. We were just in Sudbury on a family trip, and I went to my elementary school, which is about this big. It's a small little school. I was literally just right there on the weekend. She was the greatest teacher. She traded hockey cards with us before class. God, that was a neat elementary school. Anyway, who cares about my life? This isn't Dave's autobiography, though sometimes it feels that way. I was born in a log cabin. I wasn't. I was born at the general hospital here in town. Anyway.
Dave?
Yep.
Sorry, can you just go back to the slide before?
I can, but I choose not to. Yeah, of course.
And can you just explain to me?
Yeah.
Okay, so you said C and B are between?
No, I said A
A and
and
B
B
are
are
between?
between. A and B are between.
Can you explain why?
Well, different subjects get different levels of A. Right? Look, A has G1 and G2, or G3 and G4. Within A1, it's 1, 2. A2 is 3, 4. It's different people.
So how do you see C? Like, I see A and I see B, but I don't understand how to read C. How is it different than A if you just read it?
Look,
They're both getting
there's.
this and they're both getting this.
Okay, we can make this up into a thing. We can say that A is biological sex, male, female.
Okay.
Okay, and B is implicit or explicit memory.
Okay.
And C, that's a retention rule of 5 minutes, 1 hour, and 24 hours.
Okay.
That's how you can think of it that way, because it's repeating. Okay? Does it make sense now? That A and B, that subjects are within A-B interactions.
That makes sense.
It does make sense now. I'm happy.
I wasn't looking at
I
the
see. I get it.
information in
I
the
got
middle. I was looking at the way they were.
The way they were.
Format on notes.
Right. Shattered
It's like,
pictures.
yeah. So if that said G1, G1, G2, G2, then that would be C, B, or between. Right? Thank you.
Just remember, this is actually a lot easier than you think it is. It really, really is. And even if you're having trouble with it now, within a week or two, you're going to be so used to doing this that you're going to say, how did I ever make mistakes when you first figure something out? But the second thing you're going to say is, oh, it's so easy, but this stuff is hard, therefore I must be doing it wrong. There's a real failure of metacognition in this stuff. No, seriously, like that happens to everybody. But you have to actually realize this, really it is this easy. So 6 per group. So let's work it out. Any other questions before we go to the thing? The source of variation degrees of freedom table. Okay, so it looks like this. I listed A first because it comes first in the alphabet. There's no real reason to go A or B first, but A, B, those are both betweens, and then we go A, B. Subjects are within A, B. C, C by A, C by B, C by A, B, C by S within A, B. One, 20. Mitchell.
Okay, so bringing this back just so I understand.
Yes.
The expected value for A would be A plus B plus AB plus subjects. AB.
Yes.
Test that you divided by subjects AB plus error.
Yes, that's right.
Okay, awesome.
Yes, exactly. Because that first bit, in fact, is just a 2 by 2, and that's what the error term is for a 2 by 2, the thing that we call within cell, or that we call error, sum of scores error. It actually is subjects within AB.
Okay.
Yeah. That is exactly what it is. So in general, this even works for a one-way analysis of variance. You got treatment and subjects within treatment, and you're done.
The expected value for right?
So this just tells you what you're testing. A, mean squared A, mean squared B, mean squared AB. You're going to test them all with mean squared S within AB. Mean squared C, you're going to test by C by S within. All these, in fact, are going to be tested with the same error term.
So two nice ones.
Question. It's a matter of just practicing these things.
So given on a test, would you give us the SV column?
Oh, God, no. What I might do is give you that and say, what's the design? In fact, I will guarantee you I will do that on the final exam. I will guarantee there will be one where I give you this and say, what's the design look like? I can guarantee you there will be others where I give you the design and say, what's the source of variation degrees of freedom table? Oh, I'm totally doing that. It'll probably make up 40% of the final, of the points on the final exam. Somewhere between 40 and 45% of your points.
What's the source of variation?
Yeah.
Absolutely.
So, to determine the design, you would
Look at this.
To determine that design, you would look at this
So all of this,
and then figure out what the design is. What's
it's pretty much its own thing.
the table? What's the sort of other table look like?
But
Yeah.
the source.
Here.
You identify variations on the
Is this-
table?
I understand.
Oh, how do you-
I understand.
Oh, the source of variation?
Yeah.
B is not in here.
How do you mean? I don't understand your question.
You said like
Yes.
you would ask on the test.
Also,
Yeah.
plus
How
S.
you might identify the source
So this is
variation.
pretty much S.
What I would want to do, if I give you this, for example, I would want you to be able to tell me what the design would be.
Can we
Yes.
like talk about that? Because
Sure.
I only know how to type the design like looking at this table.
Well, look, if you look, no, that's
Like you
That's
can
the
see
design.
this.
That's the design. But if I look at this, I can say, look, what are the between subjects factors? How do I know what they are? They're the things listed before subjects. So, and also that subjects are nested with these. So it's got to be A and B. How many levels does A have? Don't look back at the design. Look at this. How many levels does A have?
2.
How many levels does B have?
2.
Well, that's pretty easy. So far we know we got at least one of these. And we know that we have different subjects in each group. Subjects within AB. Oh, good. 1, 2, 3, 4. Oh, we got another variable. It's a within variable. How many levels does it have?
C is 3.
C has 3 levels, right? Because we can look at this and go 2 degrees of freedom. And then I'm not going to write it again because I just don't feel like it. You might wonder why am I telling you how to do this? Well, when you read an article, and they tell you about the design, they don't always give you a nice picture showing you that. But they will show you, they'll tell you what the analysis of variance was, how it works. You can then go backwards from that and figure out what the design was.
There's 6 subjects.
For my purposes, it's very useful knowing how to do this because when I review articles for journals, about 10% of the time they've done the stats wrong. And I look at their analysis and I rebuild what the table looks like. I go, that's no, you didn't do it right. Which is a weird thing to write to other professionals in a review. Yeah, you should probably do your stats.
Because there's no minus one, so there's just 2 dimensions of both.
Or you made these up, and I don't think you did that, so you did it wrong. It happens.
That was fair.
When they fix it, everybody's happy. So you can go from design to source of variation using freedom table and vice versa. You should be able to do that. And you will be able to do that because we're going to go through a lot of these. But yeah, I can guarantee you that a bunch of points on the final exam. I'd say 30 points of the 85 on the final exam will be, or whatever it is, 80. So 3/8, that's 37.5% of your final exam grade will be doing this. Because I've used the same final exam since I did that. You can ask Lori if she wrote it. 1997. You can ask Kia, who wrote it in 2002. In a different university. I don't care. I just take it from university to university. It's the same exam. It's a good measuring instrument. Questions? So we're good on this?